Salams, hello and good morning. This is Jawad Ahmed Fareed. Welcome to ITC's tutorial for week 2. Today we'll review some of the key lessons that should have been obvious, should have been learned, should have been picked up while you attempted the quiz for week 2. Let's start. I want to start first with a list of non-CS lessons. I think the most important lesson that we wanted to emphasize, and some of you picked up on that, was that the quiz wasn't the objective. The preparation you did for the quiz was the key goal. So the pre-release was the quiz, not the quiz. How you approached it, how you solved it, how you attempted it. Somehow you also managed to figure out along the way that it was okay for you to ask for help. It was okay for you to collaborate, to work together, to figure out and identify both of the challenges and the solutions to those challenges. I think this was a key takeaway. And one big side benefit advantage of this is that as a batch, as a class, you mashallah all come together very, very quickly, and it's just been 2 weeks into the program. We normally get to see this level of bonding happen towards the end of the first term. We're now seeing clear signs of classes working well together, groups working well together, gelling together, anchors within each class, people who are the go-to resource that you go to ask for help, ask for question, and generally tend to have solutions and answers to the challenges that you're facing. We are across all 5 sections, we've seen anchors emerge, pillars emerge around which classes are now coming together to attack problems together as a group. So that's a big thing. So that's one. I think the second big lesson that I want to emphasize is, if you remember the E. coli versus Linux paper, nature versus human programmers, I think one of the key lessons, key takeaway from that reading was that stability is a function of change. If you want to build robust systems that will stand the test of time, you have to minimize the amount of change those systems go through. The pre-release and the way the pre-release was structured and shared with you, especially the addition of the Collins dictionary at the last minute, was done to emphasize one key point. If you take a system and you change it again and again and again, there's a reasonable chance that you will make mistakes. So if you think in terms of the sequence that it took for you to go from 2-word combos to 7-word combos, there was a lot of mechanical, repetitive work that required you to go out and change things, and that broke a lot of things for a lot of you. That was one. I think the second big component was that when we added the Collins dictionary, 280,000 words an hour before the quiz was due, it crashed laptops across the board. This was anticipated and expected. We expected that this is bound to happen, but the reason for doing it was to make sure that you understand that changes at the last minute are a challenge. Sometimes we have to do things the wrong way to learn how to do them the right way. So that's one list. There are a couple of other items also that I want to talk about, but I'll talk about them a little later. There are some bonus sub lessons that we all found out. Some of us knew and were aware of them, but we didn't know how to. So you do know, and you now are aware of the fact that you get a free Office 365 license with your email address. All you have to do is go to the Microsoft download page, download Office 365, and then simply log in and sign in with your email address, and presto, you have access to the full Office 365 license as a student at IBA Karachi. So that's one. I think the second part, and this goes back to collaboration, seeking help, not walking alone, is number 2, old African proverb: if you want to walk fast, walk alone. If you want to walk further, walk together. Very, very meaningful, very, very apt application to the current context and the current scenario. Collaboration helps everyone. Remember, you are not alone. Not just with respect to your classmate, but also with respect to the resources that are available to you. By the end of this week, we will actually have a list of TAs who are working through all sections. You have both me and Wasim as your instructors. You've got the anchors that we spoke about, people who are cracking, attacking, and addressing these problems earlier on. First, they're the first to get them sorted. It is perfectly okay, perfectly all right for you to ask them for help and guidance. Now, help and guidance does not mean that you ask them for the sheet or the work or the code that they've created in general. Help and guidance simply means, I need to understand how to do this. Could you explain or show me how to do it? And then do it yourself. Because if you've seen how quizzes are structured, we assume that you've built the sheet yourself. We assume that you're able to customize it. We assume that you'll be able to change it. So, and not just with respect to Excel, any other question, any other work, any other analysis that we ask you to do in this course, the underlying assumption is that it's okay for you to ask for help, but you have to do the work yourself. If you haven't done the work, by the time the quiz questions pop up, there's a reasonable chance that you will struggle with answering those questions using the tools that you have at your disposal if you haven't built those tools yourself. So that's one. And then finally, we had a lot of discussion on this. If you're going to change the time of the quiz or watch the match, that is going to jinx both the national cricket team and the match. We saw this happen. There was a request to move the quiz timing earlier to 1:30 from 4:30. In the spirit of sort of being flexible, we did that, and the end result was that the match was cancelled. So now that we've established the fact this happens, let's not do this again. So the first concept, state transitions. State and state transition are two really key concepts in the field of computer science. You'll be spending a lot of time on this as part of your degree and as part of your education. Within the context of the Scrabble game, state transition refers to the fact how the state of the board, the state of the game, the state of the players, the state of the tile changes as we move from one move to another. So when we start the game, we start with the first word. Then both the AI and the player add more word. And then from move 3, we move on to move 4, from move 4 to move 5, from move 5 to move 6, till we actually get to the final move for that specific game. How does this transition happen? This is a really key question. How does this transition happen? If you think in terms of how do you go from move number 1 to move number 2, think in terms of the framework that we've identified in the lecture for week 2, which is actors, roles, and behaviors. So a player, which could be a human player or AI, makes a word and places the word. How does he do that? He does that by creating a word from a set of tiles that are picked up from the rack, and then those tiles are placed on specific squares on the board, and then those tiles on that square on the board count as a move, and a move needs to be made in a certain amount of time. It needs to be validated against the list of valid moves and then is scored by a score, right? So these are the actors, roles, behavior that get to a point where a move or a word is placed on the board, and that move or word changes the state of the board. Now, when you change the state of the board, so when we go from move number 1 to move number 3, how does the state of the board changes? These are the actors, roles, and behavior that directly impact the state of the board. And when we talk about the state of the board, how does the state of the board change? Two things happen. First, a tile is placed on a square on the board, and that tile is scored. So this is your first set of changes. Now, when you make this move, when you make this change, there are follow-on actions that have an impact. The number of tiles on the rack goes down by the number of tiles you placed on the board, and they need to be replaced. And then once they replace, the tiles in the bag also go down because they've now moved from the bag to the rack. The things that use the state of the board include what happens to the triple word and double word squares. Have you changed those? What happens to how the board has become open? So for example, this K has opened two things. It has opened access to this triple word here. It's opened access to this set of double words here. When you do this, what that does is that it changes the path to winning for both players, and it also changes the win probability for both players. So a set of actions or sequences that originate here have an impact on the state of the board, which happens here, and then this has a set of follow-on impacts here, here, and here. So if you look at the sequence, if you read the sequence from A to B to C to D, E, these are all indicators, these are all trackers of the different stages of the state transition for the board. Now there are many ways, there are multiple ways of illustrating of showcasing state transitions. What we've done is we've used a very visual, pictorial, graphical presentation. State transition diagrams can be minimized to much more simpler forms. The form that we've used essentially is a storytelling form. This is not the conventional, traditional state transition diagram form that you're going to study later on in additional, more advanced courses in computer science. But this has been done specifically to introduce you to a very important concept that at any given point in time, the actors, the roles, the behavior, the objects that we're working with have a state. The interaction, the interplay between actors, objects, and role changes the state. In this specific case, the item that we're tracking is the board. We are tracking how the state of the board changes based on actions and sequences that happen here. And then we are tracking what is the breakdown of the transition of state of the board. Now, as you've seen, because you've been playing Scrabble for the last 2 weeks, you've seen Scrabble is a fairly complex game. And while the board appears to be a very inanimate object, from the perspective, from the concept of state transition, there's actually a fair bit of complexity built into that analysis, which is the biggest reason why we picked up Scrabble in the first place for the purpose of this specific course. Why bother with state transition? Time travel. If you study classical physics tells us that time travel is not possible, that sending information back from the future is not possible. But within the field of computer science, there are variations, there are instances where we do this, as part of everyday work. How? Let's take a look. What you see in front of you is a decision tree that tracks the state of the game as it changes. Now, there are multiple ways of doing this analysis. One is, you observe a game at play and you see it change from one sequence to the next. From the concept of playing the game, assume you're a player who's starting Scrabble at move 0. And when you have your slate, so this is your board, and these are the two slates for player 1, slates for player 2. Let's assume player number 1 is the AI. Let's assume player number 2 is the human player. Now, when you think in terms of looking ahead, if you place a word, if you make a move on the board, that move opens up a lot of additional possibilities. And then each of those moves, if you expand them, if you explore them further down the move tree, open other moves, and those moves lead to other moves, and so on and so forth. So for example, you've got a series of moves that go all the way from here to the point where you actually make the word zip, and you make it on what's called the triple word tile at the extreme left, or the extreme right, or the extreme top left, or the extreme top right corners. So you haven't made the move. You're still standing here. You're still standing at time 0. You're still standing at move number 0 at this point in time. But what we're really saying is that if I place this word now, how does it open up the board for me or for my competitor? And then if I look at the slate that I have available, as well as I have a sense of the word that have been played or have not been played, what is the likelihood that this move will come back to haunt me at some point in time in the future, or this move may pay off in a big way at some point in time. So these are each of these variations from, let's say, here to here to here, this variation that leads to the word ahead, or this variation that leads to the word bold, or this variation that leads to the word trade, or this variation that leads to the word zip. These are all possible viable paths in the future. We've identified them, but we are not sure if we'll be able to walk on them. That is a function of luck and probability. But what we do want to do is that given this explosion of paths, both here and here, what is the best possible move we can pick and play at this point in time. And then if I assume that if I play this move here, so I've come back to this point in time, let me change the marker to, let's see here. So let's assume I've played this move here at this point in time. What does that do? That basically eliminates this part of the tree. So this part of tree is no longer available because I've picked my move here. Now I only have a path that goes here, 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 and a path that goes here, right? These are all the possible paths available. And then within this, if I pick up this path, then it eliminates and remove every other path on the other side. Now only this specific option is open. So what you see here in front of you is essentially a decision tree, a game tree. And we use this game tree to look ahead moves. We use this game tree to get a sense of what is the best possible move now, given all the possible information available to us. When you move down this tree, you're moving forward in the future. When you move back up, you're moving back in time. And this concept of time travel that we just spoke about, what does this basically mean? If I look at this game tree with my Scrabble board, as I move forward in this game tree, what am I searching for? I'm searching for the best possible move. And when I find this best possible move here and I bring it back all the way 2 times 0, what I've done? I've gone back in time. I've moved forward in time. I've gone back in time. Hence the term time travel. I don't think you should discuss this form of time travel with your physics professors at IBA because that's going to get you into a lot of trouble. But within the domain of computer science, within the domain of game AI, within the domain of looking ahead moves in a decision tree, time travel is certainly possible. The challenge though is, what is the information that we bring back? So when we move forward in time, when we move forward in this direction, we identify a move, what is the information that goes back in time? What is the signal that we return when we move back from the future to the past? When we move back from a move in the future to time 0, to now. And that is the next question we answer with a topic of information compression. The field of information compression deals with signals. How can we compress all possible available information down to its essence, to the core that can convey everything which is relevant and meaningful? In the context of our look ahead engine, in the context of projecting moves forward in future and bringing them back in time with the best possible move, what we're really looking for is a single signal. How do we compress all the information that is available to us in a single signal? One signal that encompasses everything that is of relevance, one signal that represents the essence of the information we need to make a decision. So remember, what is the decision? The decision that we want to focus on is what is the move that we want to make. And what should that decision be linked to? That decision should be linked to the probability of winning. That decision should be linked to how does the probability of winning change if we play this game. So if I go from Batik, which is here, and I go to a different board which is here, and I go to a third board which is more towards the end game, can I build a signal? Can I identify a signal that emphasizes the essence of this board, that encompasses the essence of this board, that summarizes the essence of this board? And at the same time, as the state of this board changes, as the state of the board transitions, as the state of the players, the tiles, the rack changes, it tracks those transitions successfully, effectively, in such a fashion that I can calculate and estimate the probability of winning or losing the game. And that, in essence, was our board evaluation algorithm. How did the board evaluation algorithm work? Now, I want to emphasize that this is a proposed board evaluation algorithm. This is not the real board evaluation algorithm. It is not the final board evaluation algorithm. There are possibly much better, much more powerful, much more useful board evaluation algorithms available that you can look at, that you can evaluate for assessing the probability of winning or losing. But this is one algo that we picked up and we use it for illustrative purposes. We understand how do we take this much information, all of this information, how do we take all of this information and compress that into one number, which is our board evaluation score. So in this specific case, the board evaluation engine uses a couple of pieces. So first, it looks at what we call special squares. It looks at the triple word score and the double word score. Only the triple word score and the double word score. It doesn't look at the triple letter score, doesn't look at the double letter score, only looks at the triple word and the double word score. Why is that? Multiple reasons. I think one is we wanted to keep the algo simple. We didn't want you counting a lot of the squares on the board. We just wanted you counting some of the squares on the board, clearly visible squares on the board. We didn't want to confuse you too much. That's one part. But I think second part is that if you go through the research and the analysis of Scrabble as a game, there are certain indications that suggest that the triple word and triple word and double word squares actually have a lot more impact on the outcome of a game compared to the triple letter and double letter squares. There are certainly exceptions to this, but as a generic rule, as a heuristic, this made sense. So we said, okay, let's just pick and focus on special squares. That's one part. I think the second component is the number of tiles on the board. So how many tiles are currently on the board? And we use that to get a sense of how far the board has come, how far the game has come, which stage the game is at. Is it at the opening stage, the mid stage, the end stage? The reason why this is important is that your strategy, your game strategy changes depending on where you are in the game. If you've identified the fact that you are at a point where your lead cannot be overtaken, that cannot be covered up by the AI, by the competitor, then it makes sense for you to push the game to close as early as quickly as possible. One of the key rules of Scrabble is that the game is over once the last tile is placed on the board. So there are about 100 tiles on the board. If you're already at a stage where you have a 90-point lead on the competition and the game is sort of in the mid to end stage, it would make a lot of sense for you to just push the game to close as quickly as early as possible. And that does two things. One is, as you place your tiles faster, there's a higher chance that you would lead to faster tile replacement and ultimately push the number of tiles available to zero, as well as the number of tiles on your app available to zero. That's one part. Second is that the speed of your response may actually disbalance both the AI engine and your competitor depending on how much weightage they give to time differential on their side. Third is there are instances, there are variations where you may be in a winning position, but if you run out of time, you lose the game. The AI wins. So the number of tiles on the board gives us a sense of the stage of the game, and then that will ultimately have an impact on how our game strategy changes. That's one part. I think the second part is score differential between player 1 and player 2. High scoring tiles remaining. So if you look at Q, Z, J and X, Q and Z are 10 points each, J and X are 8 points each. We've plugged that in as a factor of luck. If Q, X, J and Z have not been played, if triple word tiles are within reach, double word tiles are within reach, you can still leverage these two. So part luck, part leverage can still get to a point where the AI can come up with a word that generates a fairly big lead. I think I have seen instances where I'd gone from a winning position to a not winning position simply because the AI came up with a combo using a triple word score, using the word X, that led to a massive, gigantic score of 99 on the board. And that just turned the profile of the game. If we get a chance, we'll actually walk through a couple of instances of those either now or later on in the course when we come back to discuss game AI. So when I take these four components, the special squares, tiles on the board, score differential, and the high scoring tiles remaining, I then compress that. I compress that into four pieces. One is stage, as represented by the tiles on the board. One is leverage, as represented by the number of special squares. One is differential, and this differential is essentially score differential, this score differential. And this is representative of if a given person, a given player has a significant lead over the other, also reflection on player competence. And the third and the fourth and final piece is luck. And luck is essentially the possibility that you might score or you might receive or you might have a high scoring tile on your rack, and you may be able to deploy that tile, deploy that word in such a fashion that you'll be able to eat up any lead the competition has on you at that point in time.